Well, hello and welcome to Down to Earth, the new webinar from Eurazy in association with Spacewatch Global. So we aim to bring you some of the best examples in how satellite technology is being used to solve problems here on Earth. My name is Graham Turnock. I'm the Secretary General of Eurazy, an association of space agencies based in Paris, dedicated to bridging space and society. Today, I'm delighted to be joined by Dr. Elaine Skiberas, who has over 20 years of expertise in geospatial analysis, satellite monitoring, radar, drone-derived data, and AI-based object direction. She's got a PhD and an MPhil in GIS and remote sensing from the University of Cambridge. And I'm also delighted to be joined by Ana Oliveira, who is the CTO for space application at the Plus Atlantic CoLab based in Lisbon. And she's an architect and urban planner who's turned Earth's observation for climate application scientists. More than 10 years of experience working in climate extremes and species. So, what have we got for you today? Well, essentially, we're going to have interviews with each of our speakers, and then we'd very much like you, the audience, to join in by asking your questions based on what you've heard and what you'd like to hear more about. You've got the ability to do that in the chat, so please add your questions to the chat. We'll be able to see those as we go through, and we'll try and pick out all of those. And if we can't answer all of them by the end of the webinar, then we'll try and get back to you separately. So without further ado, therefore, I'd like to kick off today's webinar by introducing Dr. Elaine Skiberas. Elaine, I'd like to also just mention that you represent Malta on the Copernicus Committee and User Forum, and you serve as a national contact for the EEA's EONet Land Systems Group, and you support the inspiration of the Inspired Directive. Would you like to tell us a little bit more about yourself and your current role? Thank you.
Yes, good morning to all. Thank you for being here and for inviting me. I currently work at the Malta Planning Authority, which is it has two roles. First of all, it is a national mapping agency, so we deal in maps which service all other government entities. As the word also implies, it's a planning authority, so we deal with urban planning. So maps in this case are very important for development of our permitting system for the country. So if someone wants to apply for to build a property, everything has to be linked to these maps. And throughout the course of this interview, I'll provide more information on the type of data we use, especially satellite data, to support these systems.
Excellent. Thank you very much.
I can also explain. Okay.
Yes, go ahead. You were going to say.
Yes, I assume we would like to talk about the use of maps in spatial planning. So maps are used to show typically districts, for example, council boundaries, but they're not just outlines. We also have information about these areas. So, for example, is this land used for building residential property, commercial areas, industry, services? So there's a plethora of information from maps, not just looking at them, but added value maps which provide information to users on the particular application of the permitting system.
Great. So what you're here to tell us about today, Elaine, is how you've used space data to improve the mapping that you're using in the Malta Planning Authority. Could you tell us what the context was and really what the challenge was that made you start to think about using space data for your mapping purposes?
Yes. So in previous years, we're talking about 10 plus years, the Planning Authority has used aerial photography to provide images. Urban development is constantly changing, so we have urban construction, the zones increase, and buildings change from being a house to apartments. So you need to have a constant rate of monitoring to monitor these changes in development. So what happened when we started using aerial imagery? These were constant over basically every 4 years. But there are some disadvantages in using aerial imagery in that, for example, they are logistically more complicated. So you need to get the permit, fly at proper times, you have specialized equipment. So we wanted something simpler, for which you can survey your area more regularly to meet these changes in urban development. So we started using drone imagery, which, as probably many are aware, provides very, very high resolution imagery. The problem with drone is that besides needing permits and good weather, it only surveys a smaller area. So we need a whole coverage for the entire country. And therefore we looked into satellite imagery. Satellite has the advantage of providing a snapshot in time over a large area. And with technology available for satellite imagery now, we can actually acquire images at very, very high resolution. And so we looked into the use of satellite imagery to meet our issues, which are regular monitoring and also high resolution images, because we need to see detail, we need to see the building outlines. And that is what we looked into.
Great. And can you tell us a little bit about, what the advantages were that you saw of satellite data and what some of the challenges might have been for you in integrating satellite data into your work?
Yes, of course. I can show this through some imagery. Perhaps you'd like to put up some images to put into the picture of the planning system. Yes. So basically, it's a portal, quite simple. You have the building outlines there. And when a user, an owner wants to change his buildings, there is data associated with that polygon, which is basically the outline of the building. So you can move to the next slide, please. Thank you. So we need to get an idea of not just a building outline, where is that building? So as you can see at the bottom, at the base, we have the satellite image, and it gives more information now, more dimension, spatial dimension into the building areas. So in this case, for example, the green polygons are the outlines of the buildings in this case for 2018, a particular second time. So we want to, as I said before, we want to assess the change in development in the buildings. So the red polygons give us an idea of where this change has occurred. And we achieved this through monitoring this change from satellite imagery. If you could move to the next slide, it provides a high resolution there. In fact, you can see. So where you have the red outlines, that is the area of building change. Okay, so using the satellite as a base, our editors can figure out where the new change has occurred. It is another rather complex system in the fact that we use changes in heights, but I will not delve into so much information. But basically, the satellite provides information for us to meet our needs, to monitor the change in urban development. And this has been done for all the country using satellite imagery. So we have a snapshot in time of the satellite imagery.
Great. And were there any challenges? I mean, how much did it cost you to get hold of this data? Is it refreshed frequently enough for you? Could you integrate it into your systems easily?
Yes, certainly. Satellite imagery comes at a cost because in this case we had to use commercial satellite because we needed high resolution as compared to freely available lower resolution imagery, for example, from the Copernicus program. So there is a cost. Yet saying that, there is also a cost to get aerial imagery, and in fact the cost is significantly lower using satellite imagery. There has been a mental change to our editors because they were used to aerial imagery, so we need to train them to use, to have a mindset to interpret satellite imagery. The advantage is that satellite is regular, so there are passes, for example, in this case of a Malta, I'd say every week, at least if not twice a week. And there's also the advantage of archive data. So in this case, we could use imagery from previous years and compare it to, for example, imagery from the past month, for example. So you can do this change analysis because of the presence of archive data. So you can select imagery at will for particular time periods.
That's great, Elaine. And is this now absolutely standard in your work, or was this a pilot? Is it ongoing now, I suppose, is my question.
Yes, it did start as a pilot indeed, because as I said before, we're used to aerial imagery, so it needed a sort of a few months of training to the editors. It is now part of our standard practice. In fact, we are going to acquire new imagery for this, new satellite imagery for this year. We have a workflow going through, which needs a quality control of the whole workflow from acquisition to delivery. And the data is available on our geoportal, so the public can also access the satellite imagery and overlaid with their building outline. So one can zoom in, so to say, to their particular building and see what's in the area and the respective permits for their building site.
And would you recommend this to other planning authorities, or were you in a particular situation where it meant this was sort of a more obvious choice for you than it might have done for another planning authority, either in Europe or more widely?
Mm-hmm. Yes, indeed. Certainly, it is recommended. In fact, most I'd say personally, because of the use of archive data, the primary stumbling block is cloud coverage. Obviously, the satellite is above the clouds. We are lucky because we're in the Mediterranean, so we get quite a few sunny days as compared to Northern Europe. So the chance of getting a good image which is cloud free is pretty easy, because obviously you have a cloud and it's the shadow and the cloud itself will basically cover the land area. You will not see anything. So it depends on the region, I suppose, and also on the amount of funding.
Great. I mean, would it be possible, do you think, to do it with different type of satellite data in regions which will cloudier, using radar data, for example?
And for this purpose, yes, radar data would be used for measuring height data, which was also an important element. In this case, we did use height to have change in buildings. Yes, in fact, that's another thing we can also look into the using of radar imagery. There's also the point of resolution, spatial resolution, that radar imagery is not so, it does not give the same high resolution as in the colored imagery. In this case, it is, as you can see on the screen here, it is a 15 centimeter resolution from the satellite, which is pretty high and used for our needs.
Amazing. Thank you very much, Elaine. That's fantastic. So don't go anywhere, because we'd like you to answer the questions at the end. But I'd like to now move on to our second speaker. So welcome, Anna Oliveira from the Atlantic CoLab collaboration. Just to say that Anna, also to give a little bit more information, that your role within the CoLab is really in particular on heat waves and health. But you've also been looking at multi-hazard solutions generally. So could you tell us a little bit more about your role, about how the CoLab came about, and what problems you're trying to address?
Yes, absolutely. Can you hear me well, I hope?
Very well, thank you.
Okay, so yes, so the CoLab Plus Atlantic, starting by the institution, was created back in 2019, but the ramp-up phase was since 2020. The collaborative laboratories in Portugal is a public initiative to fund private non-profit institutions to de-risk knowledge-based solutions that can then be uptaken by either the industry or the public sector. My role in particular as Chief Technology Officer for Earth Observation Application has been mostly focused on climate risks, climate hazards and risks, and trying to put into production solutions that are focused on the local scale, because we have plenty of data and products coming from the European scale, the global scale, and we focused mostly on these hazards at the local scale. So for cities, regions, this is our comfort zone. I myself am specialized in heat waves, both in land and sea, and I did my PhD in this regard, but I also oversee the full team, which is also working on other types of hazards, such as sea level rise, storms, and coastal floods. So in the end, what we try to do together is to offer some kind of solution that looks into these multiple hazards on the weather and the climate scales, and going beyond the hazard itself, also to the risks. So to assess what kind of losses are the outcome of the incidence of these hazards. For example, human life loss in terms of heat waves or air quality or compound events. and infrastructure damage in the case of sea level rise and coastal flooding. So these are the challenges that we typically focus on.
Thanks very much, Anna. And what sort of kick-started this? I mean, obviously, hazards like coastal flooding have been around, forever, but obviously we've seen climate challenges increase over the last few years. Who prompted this initiative that you've taken? Was it you, or were you responding to a sort of call from the public sector to do more on this? Was it a bit of both?
Yeah, so it was more, I would say, a tech push origin, in the sense that it's something that we as a group believe is needed. Myself as an urban planner, I was on the other side because I worked in the industry before taking upon this role. And I've seen plenty of special planning regulations. And in Portugal, you are demanded to do this risk mapping, just like Elaine was describing earlier as well in Malta. But the problem I have seen is that often the amount of hazards that are analyzed are not, let's say, complete. Some hazards are missing, and the temporal scale of this analysis is rather limited. For example, in Portugal, we do the revision of the PDM, so the regular planning regulation, every 10 years. And in 10 years, a lot changes. And with the climate forcing that we have right now, in 10 years, the trends that we calculated 10 years prior no longer apply. So it's more about our conviction that this is missing, something that looks into these temporal scales in a more updated manner, kind of serving at the same time as an early warning solution for the upcoming extremes in the next days, but also as an outlook tool for climate projections to produce scenarios, which is something we feel is missing.
Great, and that's very clear, Anna. And you mentioned that some of the risks and hazards aren't really sort of covered currently. So which are the sort of hazards and risks that you're bringing into scope here that weren't covered in the past?
Yes, so I would highlight those that I'm more comfortable with in terms of the scientific expertise that we need to pull them off. Heat waves and air quality come to mind, even though we already have some kind of monitoring for air quality, for example. The demand from the directive is 1 station per municipality, or even not as much as that. This means that we cannot map in a city the air quality unless the city push towards this. In terms of regulation, is not a must-have. So it's something that the cities decide to do at their own will. In the end, when we do urban planning regulation, both urban climate, so heat exposure, the urban heat island effect, is not accounted for unless the city planners are proactive and go beyond what the regulation states. But what I've seen in practice is that very few cities, very few regions and municipalities have enough economic capacity to go beyond what's the basic regulation demand. So these risks that are related to human health or urban health, if you will, they often are missing, while the infrastructure ones are more or less already accounted for, because those are already part of the regulation demands.
That's very clear. So, I mean, reading between the lines, what you're saying is the cities can't afford to do it on themselves. So you're proposing a solution that could apply to multiple municipalities, where they can really take your solution and with a minimal, I guess, amount of adjustment, produce actionable information for themselves. Could you say a little bit about how you actually use the satellite data to do that without getting super technical? Thanks.
No, absolutely. So I'm very pleased to go through our methodology, let's say. So basically, we seek in situ sensors, because we don't work with Earth observation as a standalone product. We work with multiple sources, and in situ sensors and ground measurements, direct observations are always for us the ground truth and the response variable if we use the data science lexicon. So we start to use these sensors from a commercial provider. It's called NetAtmo, and these are owned by citizens. In urban areas where the urban heat island effect is greater, that's always where these sensors are more available, because we have plenty of people there. And we can use this freely to map the relationship between the context, background conditions in terms of weather and climate. So you can think about the weather forecast that we see usually in the news that has a pixel size of kilometric scale. And we can establish relationships by using Earth observation in high resolution. And in high resolution, I mean between dozens of meters up to hundreds of meters. So not very high resolution, but high resolution. And we can use these predictors related to the vegetation, the land cover and land cover change to map what is the urban climate in the city. If we can pull off the first slide that I shown you, by merging this data together, we can offer at the same time a single model, it's a machine learning model, that at the same time offers you an early warning tool in the sense that it downscales the weather forecasts for the upcoming days, but also as a climate projection tool, because you can downscale climate projections, and in that sense you can tweak the land cover to see what's the impact if you change a given area of the city to become a park, or if you densify it. So in this slide, you are actually showing combinations of scenarios, in this case, without changing the land cover. But now if you go to the next slide that I shared with you, you can also test it out with land cover changes with a given climate projection. So here we are looking into the future heat waves in Lisbon, and you can see from the regulations that we have in place, the locations where buildings are expected to be built and parks that are expected to be also implemented. And you can see the added value or the benefit or the loss of acclimatization due to these implementations and these regulation shifts. And in the end, it's a single model that serves as two tools for urban planners, but also early responders.
That's amazing. Thank you for showing the images in particular, Anna. That really brought it to life. So how are you getting on now with taking these products to municipalities and obviously encouraging them to use them and factor them into their planning and their work more generally?
Yeah, so until now, I have received very positive feedback from the public sector, especially technical people working on municipalities. They see it as useful. Sometimes they ask us to produce analysis for them also as, let's say, consultancy type of studies. In the end, they prefer simple maps when we are talking about urban planners, because they are not looking into the next days. They want the typical map, and this is more about the climate projections. But when I go, for example, to medical doctors or civil protection, they are more concerned with acute events, so the next few days. And in that sense, they want to know where the heat is going to be stronger in the city, and they overlap this with the vulnerable population, because in the end, if your hazard is the greatest in a certain area of the city, but no one lives there, then it's not as much as a problem. So you always have to overlap these two dimensions together. It's not the hazard in itself.
Thanks. Well understood. And what are some of the challenges that you've encountered in trying to roll this application or these applications out, and how have you overcome them? You know, maybe it's budgetary, ability to interpret the data, capacity to really act on it. I mean, what are some of the challenges you've encountered?
Yeah, so the challenges are, I would say, mostly about the uptake in terms of budgetary constraints, because the public procurement regulation, there is some gap in the public procurement regulation concerning collaborations in nonprofit, let's say, context, environmental context, because you do have acquisition procedures that are very demanding, but for nonprofit institutions like ourselves, it's hard to go to this public procurement, very heavy regulations, and go through the public procurement procedure, and we feel that there is a gap to support this. So the way we go around, it's like everyone else, through grants and proposals that are, let's say, established at the national or the European level. And usually the municipalities come to us to help them out, and they prefer this way because in this way we also offer them the opportunity to have some funds to ensure that they have people in-house collaborating with side by side. So in the end, this has been the solution mostly, and I think this is no secret because this is a reflex of the European, let's say, landscape. On the other hand, there is also some lack of understanding. I wouldn't say at the technical level. The technical level is well prepared for, but if we go from the technical personnel up to the political level of decision making, because it's not something that translates into an acute loss that is very strongly communicated, they often don't recognize the advantage for them. So there's also a lack of literacy in terms of the climate benefits in the long term. And there's also a difficulty there that I think could be solved with some kind of literacy, also some push from the communities.
Thanks. And you mentioned the funding. I mean, is that supporting this on an ongoing basis, or is it just enabling you to do it as a pilot for now? You talked about some of the, I think, the European funding.
So we, for now, have it running in Lisbon daily. And because we are partially funded by the state, so we are not 100% funded by grants, we are able to keep on producing this and have it in operational mode. So this is, in the end, our goal is to have at the same time some pilots to improve things, but at the same time to keep it operational, because otherwise it's hard to see the implementation in practice.
Amazing. Well, thank you very much, Anna, for explaining that. It sounds like a really fantastic application. And personally, I'll be going to Lisbon later this year. I'll be interested to see whether we can find out a bit more about it when we're there. So now, really, this is the opportunity for the audience to ask their questions. I think we've got a few. Let me just see which we could start with. Oh, we've got quite a lot here. So I'm just going to go down to first question we've got. So there's one from Dawood. So he says, thanks for your very interesting talk. Here we are. I've got a question for Elaine. Do you have any ideas for tracking and monitoring urban change in the vertical dimension? So we were just talking about that a bit, weren't we? For example, could we be using high resolution multi-temporal radar data or LiDAR data? I think you were actually getting to this, Elaine, so you want to say a little bit more about it?
Yes, thank you. I think it's a really good question. In fact, indeed, in Malta, we have used LiDAR data. So for when we assess temperature changes, besides the 2D satellite image, we use our LiDAR data, for which we create the digital surface model. So basically, that's a 3D with the height. And using changes in this height, so LiDAR data for 1 year minus the LiDAR data for another year, we could detect areas of urban development change. And also, so for those particular areas of change, we would visualize the actual what happened basically on using the satellite 2D image. So it's a combination of satellite imagery and LiDAR data. So that is, yes, indeed, LiDAR data and elevation data is part of our workflow. And I might also wish to note that we also use AI. I've not had the chance to mention it there. So we're looking into uses of AI to make this process faster, so less sort of an also semi-automated detection of high detection from the LiDAR data.
Thanks very much, Elaine. There's another one that Betty's just forwarded on, which is a question for Anna. She's really, and this is getting into the point that we were talking about a little bit, but have you had feedback on how usable the maps are that you're producing? Are they generating the right content that people need? Are they sufficiently easy to understand and interpret and use? How are you getting on there?
Yeah, so the feedback I got is that everyone loves maps. The problem is when you go to maps that are temporal series. So when you have a cube of data, so often people prefer, non-expert people, and by non-expert, I mean non-scientists. They prefer to have dimensionality reduction. So in the end, for an urban planner, they prefer maps, but these maps have to have no temporal dimension if possible. For example, what they prefer in Lisbon is to have the typical map for the summer urbanite island and then an alternative map for a heat wave event, the typical map. In the end, it's very hard to offer this as simple as this because we have many different weather types, and in which weather type, being a coastal estuarine city, you have different patterns of the urbanite island, but in the end, this is what's most useful because the decision for them sums up to a map decision. Should we build here or not? So if you have too much variability in the maps that you offer, it's hard to take this decision. So we need to do some kind of post-processing to these maps to offer those that are more significant for the urban planning decision that has to be taken. But then if I talk about the public health and civil protection, they like to see the maps, especially if the maps show you some kind of synthesis of the heat wave that is coming in the next days. But in the end, what they always ask is to be able to pinpoint on the map a given neighborhood and download the CSV file to open on an Excel sheet to then see the temporal resolution, because they need the temporal resolution to see the profile of the day, to see the profile of the week, and the easiest for them is to use Excel. So a CSV file is needed. So yes, although the maps are needed to do this dimensionality reduction, the dimensionality reduction aspect is always needed in the end. And if we can translate, for example, air temperature into a color scale of hazard, or better even, if we can adjust this to the vulnerability of the population and offer a red, amber, green map of the risk in itself, that's the best we can offer them. So yeah, the maps are useful, but they always need some kind of post-processing, and it's a use case decision to the way we post-process them.
Thanks very much, Anna. That's very clear and very insightful. I've got a question for Elaine, which is really just tell us a little bit more about so the question is, can you tell us more about the Copernicus Land Monitoring Services? This is the geoportal where users can browse land-covered data. Do you use this? You've mentioned you're using commercial data, so I don't know what the connection might be to the Copernicus Land Monitoring Service, but if you're using this, tell us. If you're not using it, fine, we can move on.
Yes, we certainly use it. In fact, it ties into what Anna was saying, where a map is not just a map, it's you actually get information from it. I have a screenshot, I think, to explain this. It's the next slide. There, in fact. The top one is what we derived from the Copernicus Sentinel image. So basically, the Copernicus program offers free satellite imagery, various types of imagery, as in radar to visible and near infrared at all ranges and various resolutions. And we had processed the satellite imagery to create a land use map. So it's not just basically, as you can see from the thematic legend there. So basically, each pixel is associated with a particular use. Is it used for residential services? Is it what type of grassland or agriculture? So it provides value-added data, more information than just your plain satellite image. The EEA portal, EEA is the European Environmental Agency. It has a data viewer, which is very user-friendly. We use it a lot, and basically each member state provides data for the production of such maps. These include things like imperviousness, grasslands, forestry. It's used a lot for assessing climate change analysis and policies. We use it in conjunction with our policies on urban development. So we have a rate of change of urbanization. It also has a particular the EEA has a particular portal, and a special one, which is called European Ground Motion Service. Again, this is all freely downloadable portals where one can download data. And this European Ground Motion Service detects motion of the ground on millimeter level. And so it can be used for things like assessing subsidence of historic buildings, for example, the effect of infrastructure and groundwater movement on historic buildings. So there are very particular case studies where one can download free data, not just the satellite imagery, but also the service data, so ready-made data, which one can input into their own policies and applications, depending on which entity they are from.
Great. So you're using this really for much more general planning purposes. We heard a little bit earlier about the specific sort of building monitoring satellite data that you were using that was more commercial data, and then this Copernicus data is for sort of more general monitoring purposes. Is that right, or are there specific use cases?
Yes, indeed. First of all, being that it's free data, it's lower resolution, but it doesn't mean that it's not usable at all. In fact, the fact that it is value-added data, as I said, for example, let's just take an example, impervious layer or built-up layer. So the layer is temporal, so is available for various years. So therefore, one can carry out analysis on urban development over time, and we can input our own building layers into our GIS system, and therefore make our own analysis for predictions, for example, simulations, or past analysis for policy purposes. So it is lower resolution, it's free data, but it also has a high temporal sequence, so you can get data for various years and various types of data sets. And therefore it is, you can merge it with your own data for your particular application.
Great, thank you very much, Elaine. I've got a question for Anna from Albert. So he just asks, could you elaborate a little bit more about the satellite technology you use for your solution? So my understanding was that you were essentially using you were using in situ data from private individuals as a baseline to then make general weather predictions much more accurate. So is the satellite input coming into the weather prediction, or are you taking other satellite inputs as well?
Yeah, that's exactly it. So we basically fetch the weather forecasts for the full country or Europe, and then we use the satellite data to establish local specific relationships with that weather context, with the in situ sensors has been the response variable. So in short, Earth observation is part of the pipeline as a predictor, and the type of satellite technology that we use is only Earth observation satellites that are open. We don't use proprietary satellites. The type of products that we use are mostly related to land-use land cover, also vegetation type and phenology, and also land surface temperature. Land surface temperature does not come as one of the predictors. That's the only exception. In the case of land surface temperature, it serves more to benchmark and to cross-check in certain events when we have free cloud cover and heat waves, how this relates with the air temperatures that we are downscaling. But in the end, the predictors are mostly related to slow varying products like land use, land cover change, and vegetation phenology and type.
That's great. That's very clear. And when you say you're only using open data, is that because it's free, or is it because it delivers exactly what you need anyway without the need?
No, it's absolutely because it's free, because what we see is that there are so many bottlenecks for such a solution to be implemented by the municipalities that we need to do it as low cost as possible. So the best we can do without a burden of private Earth observation, because it would not be possible to offer this with a subscription level service within the boundaries of the public procurement regulation if it were based on proprietary Earth observation data. I mean, when overpass is very costly, rather alone if you have recurrent ones. So that's the reason, yes.
Does it end up limiting what you can do if you're just using the open data?
No, in our case, no, because we are targeting full municipalities and regions, and our comfort scale is the 100 meter, 200 meter pixel size. And this is not microclimate, it's actually in the boundary between micro and mesoscale. So it's more than enough to have free data coming from the Sentinels and the Copernicus services. Indeed, if we would have very high resolution, it would be useful to explore some use cases, but I would argue is not something that is ready to be implemented on an operational capacity.
Thank you, Anna. And I've got a question from Alban. So she's asking, just following up on Lorenzo's questions, she's wondering, what's been the most effective way of engaging commitment at local government level? And are you affected by changes in the political composition of local government in getting that ongoing commitment?
Yeah, so I think well, actually, I had the third slide, if you can pull that off now. Our best bet, and this is the second, yeah, that one. So our best bet is that if we overlap all the hazards and all the risks in the medium to long-term perspective, so the climate projections and the scenario tool together, and if this information comes to the population, then there is a demand coming from the population to these political stakeholders. Because what I feel is that going directly to them, unless they have very, let's say, special motivations, usually they are worried with the next election, the day-to-day decision making, and this kind of long-term benefits to the society that do not have a profit associated this, so economic profit directly associated with this, is difficult to convince them to invest on this kind of R&D and to put it into operation. So in the end, I don't have a straightforward answer to give you in the sense that this is successful. We were successful already with this on this and this case. It's still a work in progress. And our best bet is that it's about climate literacy and having straightforward solutions, going to the population and expecting that the population actually starts to demand this as kind of a must-have to the political stakeholders.
Thanks very much, Anna. In fact, I think you've also answered the question for Lorenzo, which was in a very similar space. I'll just put that up, but I think you gave a great answer to that question as well.
Yeah,
excellent. Well,
I agree.
Go on, if you had anything else to say, go for it.
No, I was just going to say that I agree. I already had read that question, so I tried to address them both.
Fantastic. Well, I think we've had a great range of questions. I think we've covered them all. I'm just checking to see whether there are any more. I don't think so. So in that case, I'd like to thank both of our speakers. Really insightful presentations, and I would hope that what you've shown here that can be done where you're working can be extended much more widely. Obviously, we talked a little bit about some of the caveats, the ability to access clear skies, but it sounds like what you're doing here is very relevant to other planners and urban managers elsewhere in Europe, and really part of the purpose of this webinar is to bring your case studies to a wider audience and inspire others to follow your path. So I'd like to just wrap up there by saying that our next of these webinars will be on Monday, the 17th of November at the same time, 11 a.m. CET. And this time we'll be focusing on the Arctic maritime sector, so a very different area with a focus on navigation. We'll have David Arthurs from PolarView, who are based in Denmark, and also Laurent Bertino from the Nansen Center in Norway. So I think on the basis of today's webinar, we can look forward to a very insightful set of presentations, and I really hope to see as many of you as possible in a month's time. Thank you to everybody in front of the screen and behind the screen today. It's been a great team effort, and goodbye from all of us.
Thank you.